Hello friends, welcome to our lecture 9 on differentiation of other miscellaneous problems. So we are going to give the heading to this lecture as miscellaneous problems, okay? Miscellaneous problems on differentiation. In this lecture, we are going to look at question number 36, 37, 38, 39. These four questions and question number 41. Okay, so keep your textbooks ready. In the previous lecture, we had done slope of the curve problems. These are questions which are very often asked in the examination, and differentiation as a chapter itself gets adequate coverage in the examination. That is why I have done it in the form of 9 lectures. So it is very important for you to practice it adequately, not only to do well in differentiation but also because integration cannot be done without differentiation. So first we have to learn differentiation thoroughly. You have to practice differentiation thoroughly before we start with integration, okay? Because integration is a reverse of differentiation. So in the next lecture series, we'll be starting with integration. So I urge you all to practice the 50 problems in this exercise over and again before we start with the videos on integration, okay? It's very important that you're thorough with these 50 problems. Then integration becomes very easy, okay? So let's go to question number 36. What does this question say? Okay, so these are all small, minor, easy problems. But they don't fit into any of the above categories. That's why I've been putting them into miscellaneous category. Look at question number 36. F of x is given. They're asking you to find f dash of 5 and f dash of 8. Subtract the two and find the value. Okay, so let's write it down. F of x is x square minus 6x plus 8. F of x is x square minus 6x plus 8. So question is asking you to find f dash of 5 minus f dash of 8. Okay, so let me find f dash of x first. 2x minus 6. So first let's check once if I've written down the question correctly. Okay, x square minus 6x plus 8. That's right. So f dash of x is right. So let me find f dash of 5. So put 5 here. 5 2s are 10 minus 6 is 4. Let's find f dash of 8 also by putting 8 in x. 8 2s are 16. 16 minus 6 is 10 here. So f dash of 5 minus f dash of 8 is 4 minus 10, which is minus 6. Okay, this is the value that I have got. Now look at your options. The options are all giving you something like this, not a number, but they are telling you, is it f dash of 2 or f dash of 3 into f dash of 2 or 2 into f dash of 2. We can know only if we find f dash of 2. What is f dash of 2? Substitute 2 in this. 2 2s are 4. 4 minus 6 is minus 2. So we have a minus 2 here and a minus 6 here. But if I multiply this with 3, I would get minus 6, which means 3 times f dash of 2 is nothing but 3 into 2 minus 2, which is minus 6. So my answer is 3 times f dash of 2, option B. Okay, let's go to question number 37. This question becomes a bit function of a function only, but a little bit complicated in that sense. Y is equal to, within bracket you have a function x, this is one function, plus one root function, root of x square plus m square whole power n. Okay. So let us write that down. Y is equal to x plus root of x square plus m square whole power n. Now this whole thing you consider as a capital X. Capital X power n. What is the differentiation of capital X power n? It is nothing but nx power n minus 1. Okay. So let us write that down. Dy by dx is equal to nx, n into capital X, okay, power n minus 1. But what is this capital X? This capital X is nothing but x plus root of x square plus m square whole power n minus 1, correct? Now we don't stop with this, we differentiate. What is this? This term is 1 plus this term differentiation is 1 by 2 root x square plus m square multiplied by differentiation of what is inside the root, that is 2x. So cancel this 2 into, close the bracket. Now here we will take LCM. When we take LCM, we'll get x square plus m square plus x in the numerator. Denominator will be root of x square plus m square. Close the bracket. Okay. So into n into x plus root of x square plus m square whole power n minus 1. Now look at this term and look at this term. Aren't they the same? So what is the property of indices we have learned? A power m into a power n. When the base is same, powers can be added. A power m plus n. Okay. So now here n into power, let us add. What are the powers? Power is n minus 1 here and the power here is 1. When I add, all I will be left with is only n. Now divided by root of x square plus m square. This is my dy by dx. Now before I proceed further on this, I should check up my options. What do my options say? In my options, I have ny by this, minus ny by this. Okay. So let's look at this. Now this is nothing but, this term is nothing but my original question, y. So what I have is ny divided by root of x square plus m square. This is the value of dy by dx. Okay. So this is nothing but option B. Okay students, let us go to question number 36, 37, 38 we have done. So okay, next is 38. Let us look at question number 38. Yes, this is the question. Y is equal to, let me write it down, y is equal to root of x by m plus root of m by x. Okay, then question is asking us 2xy dy by dx minus x by m plus m by x. 2xy dy by dx minus x by m plus m by x is equal to question mark. This is what the question is asking. Now before we find this, before we differentiate this, let us do squaring on both sides. How do we square on both sides? The left hand side becomes y square, but the right hand side would be x by m plus root of m by x the whole square. The whole square. Very often I find students forgetting to do this whole square. Whenever I ask them to do squaring on both sides, all they do is squaring of the left side and then these two terms. They just write this as x by m and this as m by x. No, it's not the case. We need to do the whole square. Okay. So whole square is nothing but a plus b the whole square, which is nothing but a square plus b square plus 2ab expansion. So now let us do this expansion. So squaring this, the root will vanish, x by m plus m by x, okay, plus 2 into root of x by m into root of m by x. So I can cancel this term, okay, because I can apply a single root here and make it as x by m into m by x. So this term becomes 1. This term becomes a 1. Okay. So what remains is only a 2 here. Okay. So this is all nothing but 2y square. Now let us look at the question. What do we have here? This is what we have. We need to find dy by dx. We have not yet done that. Let's do that. Now this whole term has become only 2. Keeping that in mind, when we differentiate, we get 2y square we have already here. So this becomes 2 into 2y dy by dx. Okay, this is equal to x by m. This m is a coefficient, so keep the m as it is. Differentiation of x is 1. Now differentiation of m is going to be just coefficient m. Differentiation of 1 upon x is nothing but x power minus 1. X power minus 1, when we differentiate, what we get is minus 1 into x power minus 1 is equal to minus x power minus 2. So that is minus 1 by x square. This is the differentiation of x power minus 1. So m by x square. So this is what we have. Differentiation of 2 is 0. Okay. Now please go back and look at what we need. This is what we need. Now you see that we have a dy by dx on the left hand side. Okay. Just one small correction. There is only a y square here. I don't know why I ended up writing 2y square here. So I put an additional 2 here, which was not necessary. Okay. Is it clear now? This was only a y square and I should have just written y square. So differentiation of this is 2y. Okay. So now this is what we need. We don't need 2y dy by dx. We need 2xy dy by dx. So let us write that down. We are multiplying both sides. Multiplying both sides with x. When we multiply both sides with x, we get 2xy dy by dx. This is equal to x by m minus m by x. When I multiply this with x, this x and this gets cancelled, so we are left with only a x. Okay. So this is what I have. I'm going to bring these two terms to the left hand side. 2xy dy by dx minus x by m plus m by x is equal to 0. So this is what the question was asking me to find. In the earlier days when we had descriptive paper, so question used to ask, prove that this is equal to 0. So now they are just asking you to find the value. So most likely these kind of questions would end up with a 0 or a 1 or a minus 1. So let us go to the next question. Before that, let's just tick the option. Which option has got a 0? Option A. So answer is option A. Now let us go to question number 39. Let us copy down. Y is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power n by n plus so on dot. Then dy by dx minus y is proved to be how much? Please note this dot. In one of the earlier textbooks, I remember, in the recent textbooks, I think for the past 2-3 batches, this dot has been added. So if you are having a very old textbook, you will not find this dot. And there is a lot of significance for this. What it means is this goes on up to infinity. If this were not there, then it would be difficult to prove this or difficult to find the value of this. You will know why when we solve the problem. So let's take down the question. Y is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial so on up to x power n by n factorial and so on. What is the value of dy by dx minus y? Like I told you, no, most of these proof that questions would have an option 1, -1 or 0. So in those days when we used to prove that, the descriptive part, that used to carry a lot of marks. Okay. dy by dx minus y is equal to question mark. This is what the question is asking us. So now what we will do is, let us differentiate both the sides. dy by dx is equal to, differentiation of 1 is 0, x is 1, x square is 2x by 2 factorial, 3x square by 3 factorial. Now fourth term would be x power 4 by 4 factorial. So let me write that also, 4x cube by 4 factorial, and so on up to nx power n minus 1 by n factorial, plus dot dot dot, the next term is naturally n plus 1 into x power n by n plus 1 the whole factorial, plus dot 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 dot. Okay, I'm just writing the term after this. What is the possible term? X power n plus 1 divided by n plus 1 the whole factorial. This is the differentiation of this. This is the differentiation of this. This is the differentiation of this. All these terms. Okay. Now let us simplify this. It becomes 1 plus 2x by 2 factorial will be only x. Okay. So for those of you who did not attend the permutation combination session, let me just tell you what a factorial notation is. Whenever we write n factorial, we expand it as n is equal to n factorial is n into n minus 1 into so on up to the last, all the natural numbers, product of all natural numbers. Okay, so here 2 into 1 factorial, so this becomes only x. Come to the next term. Next term is 3 factorial is 3 into 2 factorial, so this 3 gets cancelled with the numerator 3. Okay, so these two gets cancelled, so what remains is x square by 2 factorial. Now the same thing is 4 and this 4, so what remains is x cube by 3 factorial, dot 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 dot. Now this term is n and n gets cancelled, x power n minus 1 by n minus 1 the whole factorial. Now this term is n plus 1 gets cancelled, what remains is x power n divided by n factorial plus dot 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 dot. Now look at what we got. Same thing as the original question or not, right? That is why dy by dx is equal to y now. So now we have dy by dx minus y, we take this to the other side, so this is equal to a 0. Okay, now do you understand the significance of why we need this dot dot dot? If we didn't have this dot dot dot, the last term would be this particular term, which means we would not be differentiating this term. If we don't differentiate this term, we will not get this, and hence we will not get this, and hence we will not be able to say this is equal to y. So therefore the significance that it goes on up to infinity is very important. So there was a mistake in the earlier version of your textbook, which is got corrected now. So that's the significance of that dot dot dot. Okay, let's move on to question number 41. Question number 41 is y is equal to root of x square plus m square. Y is equal to root of x square plus m square. What is y1? Question is telling you y1 is equal to question mark. Y1 is just another way of saying dy by dx. Okay, so let us find out dy by dx in this case. I have asked you to assume this whole thing to be a capital X, so it will become 1 by 2 root capital X, correct? Root x differentiation multiplied by differentiation of, or let me write this as small letters but it doesn't look like a x, so into multiplied by differentiation of this term, which is 2x plus m square becomes 0. Now this 2 will get cancelled with this 2. Let's write the value of x now. 1 by, numerator already has a x, 1 by root of x is nothing but x square plus m square. Okay, This is nothing but x by y. So dy by dx is equal to x by y. Question is asking why y1. Okay, now let's take this y to the other side. So y into dy by dx is equal to x. Rather, dy by dx is nothing but y1 is equal to x. Okay, so which option matches with this? Option B. So friends, these are the problems, miscellaneous problems. I would suggest that you do problem number 40, 42, 48, 49 and 50 as self-practice, which are similar to the problems that we have done in this lecture. Now, apart from this, you can also do for quotient rule, which we had covered in our lecture number 3, and product rule also, which we had covered in our lecture number 3. You can try these problems. Under quotient rule, you can try 5, 23, 28, 32, 43 and 44. Under product rule, you can try 6 and 27. Alright, so this brings us to the end of differentiation. Please do post in your doubts on any problem that we have solved in the lectures or even the self-practice problems. So depending on the problems that you're posting, I can do the next lecture on just the doubt solving. Okay, thank you and good luck to you all.